4.1's done. Finding composites. 4.2 says one-to-one functions, inverse functions. Now we've got to discuss that. What bothers me though, since I want some good scores on Wednesday, this semester's gonna be over before we know it. I just glanced at number 3. Guys, look at number 3 on, right above, where it says section 4.2. Do you see those two functions I gave you? And then I asked you, to talk about the composites, and then list the domain of the composites. Do you see what they look like? Should I do one of those before I jump into 4.2? Just hopefully to get you ready. Okay, let me do this before I leave 4.1. Since 4.1's on the exam. Let me do this. I gave you these functions. F of x is this. And I'm doing it for a reason also. Let's thought about it. Now put on the side here, of course, x cannot be 1. And g of x is this. And x cannot be this. Now, number 1, a couple of examples here. Find the composite, written like this. And also I want the domain of that composite. So guys, any questions there? Now, I might have time just to do one of these. Did I copy everything down correctly? Is it correct? Did I make a mistake, did I? Okay. Now, if I will find this one, here goes, I better use a different color. It says you're looking for f of, blue here, f of g of x, written like this. On this one. That's what you're looking for. G of x is this. X plus 1 given to me over x subtract 2. And they're asking you to take f of that. Now, this is going to get tricky, very tricky, but that's what it means to do. Guys, I'm doing my work on the side here. It says, please take this x plus 1 over x minus 2 into the f function. You're going to take it up here. If I do, please tell me, I'm going to be very careful here. Will it look like this in the f function? I'm replacing the x with the blue. Be very patient here, so we'll not make a mistake here. Over, in place of x in my denominator, again, this. And subtract 1. You step back, make sure everything's copied down correctly. Is that what it means to do? Now, here's the work. You gotta clean that up. Guys, here goes. Please tell me, this first part, can I rewrite it, as if you agree, as this? Just that first part. Yeah. And you still got plus 1 on the end. By the way, since I have to combine with a common denominator eventually, could I rewrite, being clever, that 1 as x minus 2 over x minus 2? Yes or no? Because I got to eventually put them together. Here, I don't have to do anything with the blue, but could I go ahead and rewrite these, the x plus 1 over x minus 2, that's the way it is, but write that 1 as x subtract 2 over x subtract 2, like that 1 there at the end. Is that okay? Just try and get a common denominator involved. If that's true, on top, I have everything over x minus 2. Now, when I say everything, I got this,
Yes, sir.
plus that. Yes,
The first fraction.
which one?
The left out one.
Okay, let's see, I can look at it. What's wrong with it?
I'm sorry, I missed.
You
sorry,
missed it.
sorry.
Whoa, you're waiting for that Berkeley letter. Okay, so we end up with like 3x, is it 3x?
Yes.
These two cancel. Don't scare me. Down here, oh geez, I gotta be careful here, guys. Look at this. It's that. Will the x's cancel on top there? Well, I end up with 1 subtract a negative 2. 1 plus 2. Is that 3? Yes or no?
Yes.
Anyone tell me the final answer? Shame on you. You know it means this. You know from across the street in that middle school. At the point we are right now, it means do this. This, guys, means that. Which means this. Times, flip this over from middle school. Is that true? These will cancel. 3's will cancel. Are you kidding? There is my composite. It's X. Are we okay with that? Is that X? It's X. Right? I did this for a reason. To lead me into section 4.2, you're sure. Now, I asked also for the domain on this composite. Guys, if I just got an X, I would think, well, Professor, there's no restrictions. You may replace X, I don't see a square root involved, I don't see anything with a denominator to worry about, just X, so it should be all real numbers. But I gotta consider how I got this. I placed this into something to get the answer, is that true? Is there a restriction on this? Yeah, I think we said back here, what, X cannot be what? Negative with 2, so my domain is, I gotta point this out, X cannot be 2. And that's the only number you can't use. And that's done. Now the side, oh, I'm so glad I thought about this. Now let's find the other composite, and I think I was asking for G circle F. Also on this, which means G of F of X. All right, guys, I need to do some erasing. Oh, by the way, was I asking for this also on the handout?
Yeah.
I was, yeah, Ignacio.
In this case, we wouldn't, look at the other domain.
Not beautiful, that's what, was it Shane or Bella? Bella's concerned about that, no.
Okay.
Because after you get the final answer, that's where it took into consideration, when I got, where was it, X? I got an X somewhere. What's the final answer?
Thank you.
Yeah, it was it.
Yeah, that is the consideration for both of them right now.
Okay.
But then you gotta keep in mind, how did I get there? That's where I pick up that X cannot be 2. I know if she asked the same question. Just be careful. I'm gonna try the other way. And then I've got something to point out about this. Guys, this one says, take G of F of X. Let me point out what F of X was. It's given to me as this, 2x plus 1 over x minus 1. So I'm asked to find G of that. Let's go to my G function and replace. Here we go, guys. The G function, when I do my replacing, it's going to look like this. 2x plus 1 over x minus 1 plus 1, this is my G function, over x again, which is this. Do not mess this up. That, subtract 2. And that's my G function. Okay, guys? Now I gotta clean that up. Woo! Good I do again. Now this, please help me. Since I see a common denominator is gonna be needed. Could I go ahead on the top here, guys, and rewrite this one as this? Is this still 1?
Yes.
And therefore now they have a common denominator, which says put these together. You guys will end up with, oh, is that 3x? Please tell me, is that 3x again? Over x minus y. I'm not doing the same problem, am I? Is it 3x again? Whoa. Now on the bottom there, I'd like to put these two together with a common denominator of x minus 1. Can I do it? Let's think of that 2 as 2 over 1. If I want an x minus 1 common denominator, it may take a little more effort. Put an x minus 1 in here. Clean that up, guys. It's all over x minus 1. Squeeze that in. Now what is it? It's this business here. And I think the two x's will cancel. It looks like it's 1 plus 2. Do I get 3?
Yep.
Are you kidding? Will these cancel eventually? Will the 3's cancel like earlier? Do I get x again?
Yes.
And that is cute. You work one of these on the exam on Wednesday, you just get x. That's going first. You're going to be startled. You're saying, what? I must have done something wrong. Professor, the answer is x. For that composite, it's x. Now, hang on just 1 second. Let's see what I did here. Oh, beautiful. This is going to leave me right into 4.2. Someone in class before the break told me what the word I'm looking for here is. When you find those composites and you get an x, you're dealing with special functions. These functions that I start out with, this function and this function, because both of them gave me, what was it, merely x for the composite? There are special functions when that happens. They are known as inverse functions. Let me say just a little bit about this tonight. They are known as inverse functions. Notation, in math, if they want you to find the inverse, it's f superscript -1, usually with respect to x. Notice I said superscript, not an exponent. If it's for an exponent, f raised to a -1 is what? 1 over f. Here's a superscript. That's the notation for an inverse. So guys, these two functions are inverses of one another. So if this happens, which happened on the board here, you found the composite, both directions, f circle g, then you turn around, g circle f, both of them give the same answer, x. They're special functions, they're inverses of one another. Now here's my tie-in with what we were doing before the break. I'm not going to ask you to graph this. I'm not doing any more graphing tonight. Anyone tell me, is this a rational function?
Yes.
Here goes. Can anyone look at this real quickly and tell me, I'm not going to graph it, where is the x-intercept, just out of curiosity, located in graphing this first function? Just name the x-intercept. Someone tell me, where is the x-intercept located?
-1/2.
Here's -1/2. Shane, was that you?
Yeah.
She said, Professor, it's -1/2 0. If you set this part equal to 0 like you're supposed to, do your business there, you're going to get -1/2. Is that true? Now go down to function number 2. This one, suppose I ask you to find this for it. The y-intercept. How do you find the y-intercept? You go back and replace all the x's by 0. What are you going to get? Oh my goodness. You get -1/2 again. Is that true? So the x-intercept on the first function is actually what? The y-intercept on the second. Is that true?
Yeah.
Sort of switched. I'm going to find one more item here. I'll move from here. Let's go back to my rational function. Can anyone tell me, be careful, where is my vertical asymptote located on the first function? On this function, if you were to graph it.
1/2.
1. You set the denominator equal to 0, you get 1. Now, can you please tell me where's the horizontal asymptote on the second function?
2, 1.
Yeah, look out here, is the derivative the same on top and bottom? That's the easiest case ever, so it should be the coefficients out front, which is 1 over what? 1, is that 1? So this is y is equal to 1. Same answer. So whatever the vertical was on one function turns into what? The horizontal on the other. They're switching, aren't they? These are inverse functions. Everything's going to switch from one to the other. And we would go through and find other items here that will switch. So guys, this is the meaning of an inverse function. They use a notation f superscript -1 to indicate what they want here. But before, the textbook should have done this, and I thought about this. Before I jump really into it, there's a concern. So on the next part here, let me point out, I did this. I formed a set A, name it A, that contains these ordered pairs. -1, 2. I've got 0, 3. I have 1, 4. I just threw some numbers together. And 2, 5. I'll let that be my set A. By the way, I did have in mind a rule there to get those numbers. Does anyone see, just out of curiosity, what the rule was I had in mind? Shane?
The X and Y values are swapped for the.
Something else. I had in mind, when I put -1, I got a 2. When you put a 0, you get a 3. When you put a 1 in, you get a 4. When you put a 2 in, you get a 5. I had something in mind as I wrote my notes down to get those numbers. What did I have in mind?
If you go 1 to the right, you go up 1.
Oh, I like that, but tell me in equation form. Y is equal to what? X plus 3. You're adding 3 to the x. Is that true? Okay, now that's listed. I see it listed for me. Now suppose I say, please find, look at this, the inverse of that set of ordered pairs. Now you saw what happened over here. Now can anyone tell me, just based on this little introduction, what do you think the inverse of set A will look like? Based on what we saw just happen.
2,
Tell me again.
Would be 2, -1.
Beautiful. The very first ordered pair is going to turn around. It's going to switch. And he's telling me, Professor, looks like that. It switches around like over there. This one should now become what? 3, 0. This one, I guess, is what? 4, 1. And this is 5, 2. You guys agree? And there's the inverse of set A. Just out of curiosity, does anyone have a rule there for this one? X minus 3. Hang on. That's the name, the equation for that in the blue. True? Beautiful. Now, set B. Oh, I made this connection for you guys. Set B I brought in to look like this. This is my last set I'm going to look at with you. Ordered pairs. -2, 4. -1, 1. 0, 0. 2, 4. Looks like that. And I'm asking, please form this, or find this. The inverse of that set. First, can anyone tell me what rule did I have in mind on this set B? I think it's y is equal to what, x squared? Now watch carefully. Now you say, Professor, I saw what you did. You just interchanged to form the inverse, right? So should the inverse not be this, Professor? I'm doing it in blue. Just go through and interchange, make this one turn around, make it look like that. Make this one this, interchanging. This, of course, will stay like it is. And this will be this.
No.
Is that true? I mean, I interchanged. Did I interchange them correctly?
Yeah.
Now I've got some clever students. They said, Professor, you did what you're supposed to do. You interchanged up here on this one, it worked out beautifully. And you interchanged here. Now Bella, Vincent, are saying, hold on, Professor. Yeah, you can do that. But there's something wrong on this one. What's wrong?
The inverse is square root.
Yeah, square root can be negative.
Ah, beautiful. You think about square root, something else. What's wrong with me? This one works out nicely. This is the answer for the inverse of this one. I formed the inverse, the blue, for this one down here, and students say, Professor, you did what you're supposed to do, but you can't accept it. Can anyone give me another rationale why I cannot accept my inverse on the second one? Something's wrong with it. And sometimes it will happen. In other words, I'll tell you ahead of time, set B has no inverse. There's something wrong. Yes?
Maybe because of 4 equals minus 22.
Oh, hang on. He said, Professor, you cannot let this happen.
The multiple values of X.
You cannot let an X repeat. It would not be a function. It would not be a function. So this is not a function to begin with. I want a function. So, Bella, Vincent, Daniel, just help me out. Not a function? Not a function, therefore this thing has no inverse. Now, can't do it. Now, can anyone tell me how would I, as a clever student, know at the very initial, the beginning, as soon as I wrote this black function down, Professor, don't try it, it's not gonna work. Something in the black tells me, don't try it. It's not going to work. Shane?
Multiple of the same Y values.
Tell me again.
Multiple of the same Y values.
Which Y values are we looking at?
4 and 4.
That's the 4 repeat.
Yeah.
If you have a Y repeating, just stop, say, there cannot be an inverse. We tried to interchange to make one, but that didn't work. So if you have a Y repeating, like Shane described, you have no inverse. Guys, I'm looking at my time here, I've got plenty of time. Stop at what, 9 o'clock, 9:30, something like that, okay. Any concerns here just about basic inverses? Okay, now hang on. Now, with all that said, and all that interchanging taking place, here we go. Part 2. I thought, yes, it's time now to do this as we close down tonight. Why not? Here we go. F of X, give you a function, is equal to 3x plus 7. Let's start with a nice linear function. Find its inverse. That's my notation. We'll find its inverse. Now you won't believe how easy it's going to be to find a function's inverse. Now I'm not going to ask you to list points, list ordered pairs. Okay, but I will do this. Only 2 steps. Guys, step 1, based on what we have done, if I want the inverse of this function, and I know inverse involves interchanging, the x and y interchanges, let's interchange the x and y in the original function. So rather than f of x, which is y, let that be x. And in place of x on the right, put a y. Interchange. By the way, were we interchanged on the others? Is that what I was doing, interchanging? Please tell me, was this interchanged? 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 Is that true? I'm doing the same thing here. Now, step two, after you do that, step two, the last step, they want you to solve for y. You get the y by itself. And you'll be finished. Easily done. If I want to get the y by itself, I'm going to 7 over. Get this. Divide by 3. Guys, divide by 3. You may say, Professor, can I leave it like this? And that leaves the y by itself. I'm happy with that. You've solved for y. This is your inverse. So you get the y by itself, that's considered the inverse function. And you're done. Alexandra? So I'm saying across the street, the middle school, those kids across the street at the middle school can do this. They recognize 3x plus 7, x plus b. They may not know what the inverse of that function looks like. We do. It looks like that. That's the inverse of the original function. Now let's play around with it a little bit first. Billy, I have a question for you. Billy, could you take the original function given and name for me an ordered pair that belongs to that function? Any ordered pair you wish, an x and a y, that based on what you see, 3x plus 7, it belongs to that function.
110.
I love it. Watch carefully. You guys are blessed. Blessed to have an instructor like this. Aren't you? Okay, 110. Billy, I agree 100%. Just replace x by 1, she gets 10. And there's an infinite number of answers, I just ask for this one. Now, look at this. If this is that function's inverse, I should be able down here to interchange. If I have the correct inverse. Let's see if I do. If I interchange her answer, her ordered pair, this, replace down here x by 10. 10 subtract 7 is what? 3? 3 divided by 3 is what? Oh my goodness. Oh my goodness. Now, Alex, name another function, another ordered pair for me belonging to that first function up there.
2 and 5.
Say it again.
2 and 5. Okay, wait. I'm confused.
Don't scare me.
I just say any number.
Yeah, for 3x plus 7. Tell me another. She gave me 110.
Yeah.
Tell me another guaranteed ordered pair that belongs to that function besides 110.
A point on
Where-
the line.
Where are those letters from Berkeley? Come on.
Oh, okay, I get it.
Okay, tell me what it is. Any of them. Name one.
2 and 13.
Okay. I agree. You guys agree? Now, if he's correct, I go down here. I should be able to interchange 13 too. Let's see if it does. Fifth. If I replace x by 13 down here on the inverse, 13 subtract 7, was it 6? 6 divided by 3 is what? 2? Works. I don't know how many students I have tonight. Let's say I have 25 tonight, maybe 30. By the way, some of these classes are down to 6 or 7, by the way. Mine's not down there. It's not going down there. Okay. See what's going on here? Now, suppose I start with Mr. Park, and then go through all my students who are here, everyone who's here. Now, I want to include myself, I would throw in one. And start with Mr. Park and ask, list another one, Mr. Park, for me, and I will check it. List another one for me, my next student, we'll check it. Another one, I have the time to do, let's say, 25 students here, and they all check out. You say, Professor, goodness gracious, they're all checking out like you checked these two, so undoubtedly this inverse you found down here, Professor, that must be the true inverse. That's the answer. It's working, isn't it? What's wrong with that rationale that I would accept that after 25 students tested and all 25 worked? Why would I be a little hesitant to say, oh, it always works? It always works. Why would I be hesitant to say that? After 25 students in this class showed me correctly that their 25 that they chose did work, why would I not draw the conclusion it's always going to work? If I tried it 25 times and it worked 25 times, when you say, Professor, enough is enough, it must be working always. What's wrong with that rationale? Might there be an ordered pair out there somewhere that we have not, among the 25, tested? That for some reason, when I do this business, it would not do what it's supposed to do. Is that true? How many numbers are out there to test? We test 25, I say, how many more numbers are there out there to test? Infinite? Okay, let's see what time it is. Well, here we go. We're gonna stay here, infinite. We're supposed to test all of them. And I've been around math for long enough where sometimes professors have done this. You'll fall for it, I'll test maybe the first 10, I'll try 10, they work, I put a smile on my face, I turn my paper in, get it back, I got a 0. I still remember this professor who did that. And what was it? There was one way out there that did not work. Just so happens my 10 worked. And I smiled, turned my quiz in, and ooh, I got an A on this one, I know I got an A. Got it back on 0. There's one out there that didn't work. Now I gotta come up with some way to close down class tonight to show that this will always work for everything, not just my 25. It'll always work. And guys, here goes Bella.
Set them equal to each other?
Tell me again.
Set them equal to each other?
I didn't hear you.
Set them equal to each other?
Oh, not set them equal to one another. I know why you may have said that. That's a little something you may not have seen before. That's the way the textbook suggests you check. If it checks in this particular check, when I show you what the check looks like, if it checks, then you're guaranteed it will always work. There it goes. And it's a nice tie-in to close down. You take the function given, you form the composite with its inverse with respect to x, and you had better get x. If you don't get x, you found the wrong inverse. Your inverse is wrong. I'm pretty sure this inverse we discovered, which is this, I'm pretty sure that this is the inverse of that function. Okay, let's check it. Guys, let's take f of, this is a composite, f of this. Let's do all our work on the left there. This, we think, from all the work we did tonight, everything's connecting for it, we think the inverse is this, x subtract 7 over 3. Of course, I'm taking f of that. Is that true? Now before the break, how do I do that? I take the blue into the f function. So you guys take the blue into the f, here's my f function. So let's take the blue into it, and it will look like this. 3 times, here goes, 3 times in the f of x function. This goes in, the blue. It looks like this. Try to find it here. X subtract 7 over 3. Close that up. And it says take it into the f. The f also had a plus 7 on the end. Is that true? Is that the composite? Now to clean that composite up, these 3's will cancel. I've got x subtract 7 plus the 7. Well, the 7's also cancel.
Yeah.
What do I end up with? If I don't end up with an x, we got issues. We have the wrong inverse. Shame.
Do we have to check the
Yes.
composite directions?
Oh, beautiful. She just said, Professor, hold on. You said you've had a lot of math in your life, and I have. She says, might it work in one direction and not work in the other? She said, this. Oh, Shane, nice. She said, should also work if I did this. Should I get X again? Turned around. It should work in both directions. If not, we got issues. Here we go. This means F inverse of f of x. I'll do this fairly quickly, guys. F of x, right here, was 3x plus 7. And then F inverse on that looks like that. True? Then it says go to your inverse, your replacement. Here's my inverse. Where is it? My goodness, where's my inverse? Over here. Is this my inverse? Is that true, guys? So go to my inverse, do the replacing, and you're going to end up with, for x, 3x plus 7. Right here. Subtract 7. All over 3. Clean that up, 7's cancel. Well, I end up with x again. Yes or no? Did I end up with an x in both directions?
Yes.
I'm guaranteed then, in math, unless something crazy happens, that this is guaranteed to be the inverse of that f of x function. It's always going to work. Wow. I'm checking my time here. Any concerns there, guys? How to find an inverse? Now, I'm looking at my time, I'm thinking about the test. Oh, shoot, I should brought a copy of the test in and let you guys look at it and see if it's okay. You know, sometimes I'll make mistakes and you guys could have caught the mistakes, right? If you could see a little copy of the test first. Yeah, wouldn't that be nice? Wouldn't that be nice? Okay, that's not gonna happen. Now, since we've got just a few minutes, I think it's a section 4.2 maybe on the handout, talking about inverse functions. I will continue with that just a little on Wednesday, but most of the time on Wednesday is going to be devoted to that test. Now, a student has asked, and I'm going to ask Mr. Park, will you do it for us? The review or the thing I gave you before the break to work on, he's going to send out the solutions to that. I think there's a nice rational function to sketch on that. I think there was. And some other items to look at, just for a little practice. But guys, don't just depend upon that handout. You gotta look in your textbook and look at the problems, and I am checking homework. And those section numbers are listed on that handout I gave you. Everyone understand? Okay. Any concerns right now? Any questions? So how is it that we have, and I told my